Hello my dear friends, welcome to our channel. So in the previous lecture, we discussed how to name the compounds. We studied how to name the simple organic compounds, and then we studied how to name the complex organic compounds with functional group and without functional groups. In this lecture, we will study how to name the unsaturated organic compounds. What is unsaturated organic compounds? Unsaturated organic compounds are those compounds in which compound, double bond and triple bonds are present between the carbons. If the double bond and triple bond are present between the adjacent carbons, then the compound will be known as unsaturated organic compound. For example, I am taking here an example. You can see here C bond, C bond, C bond, C, double bond, bond, C bond, C. You can see here I wrote a compound. In this compound you can see in between a carbon at some point in between the adjacent carbon you can see the double bond. You can see the double bond, right? You can see this double bond. This double bond indicates that it is an unsaturated organic compound. So whenever in a compound a double bond or a triple bond is going to be present, at that time we should have to understand that the given compound is an unsaturated organic compound. Now we are going to learn how to name this a unsaturated organic compound. Before that, to write a compound, there is one more method is there. What is that method? Is Bondline Formula. What? Bondline Formula. To write the compound in one more way, there is one more way. That way is Bondline Formula. For this Bondline Formula, what we will do in this Bondline Formula is that we will draw a single line. We can draw this line however we want. Mostly this line will be like this, right? So you can see, so whenever I am drawing a single line, at both the ends a carbon is present. We should have to assume that at both the ends and both the points a carbon is present. So whenever a line is giving, at that line we should have to understood the carbons are present at both the ends, right? If I am writing like this, I am just writing this one as here, and now I am connecting one more line from here. And these two both ends, as you know, here it is representing the carbon, here it is representing the carbon. Now here one more end is there. When I draw the line, these both the ends are joining at a single point. See, you can see here both the ends are intersecting at a point. That point also indicates that it is a carbon, and the ends are also representing the carbons, right? You can see here, so it is also a carbon. If I am drawing one more line from here, then these two lines are intersecting at a point that is representing the carbon, and then the end which is free, that end also representing the carbon. So to write a compound in a Bondline formula is very easy. We should have to just draw a line to indicate the carbon. For example, I am taking here CH3 bond CH2 bond CH2 bond CH3, right? How many carbons are there? 4 carbons are there. See, I am just drawing a line. How many carbons are there present in this line? Here one carbon and here one carbon. 2 carbons are present. I am drawing one more line from here. So here is the third carbon. I am drawing one more line from here. Here is the fourth carbon. So you can see here 1, 2, 3, 4. I just drawn a lines and I drawn this compound very easily in a Bondline formula method. So if you are using the Bondline formula method, it will be very easy for you to draw, right? So you can see here, no need of writing these things if we are able to draw Bondline formula for a compound. This compound and this compound both are same, right? So if in a compound you can see this line here, it's a line, straight line. You can see here at the both ends carbon are there, but in between the carbons how many lines are present, that many number of bonds are present. Once again I am saying, in between the lines, in between the carbons, you can see it is also a carbon, it is also a carbon. In between this carbon a single line is present. That means between the carbons only a single bond is present. This bond is nothing but a line here. That means if here only one bond is present, then how many hydrogen atoms are present for this carbon here? 3 carbon atoms, three hydrogen atoms. Why is it 3 hydrogen atoms? How many bonds are for the carbon? 4 bonds are there. How many bonds he made with this carbon? Only a single bond he made. So the bonds which are left out will be bonded by the hydrogen atoms. We should have to understand, if the bonds are not given, only a single bond is given, then we should have to assume, then we should have to understand that whatever the bond is not given there, that many number of hydrogen atoms are present, and that hydrogen atoms are bonding the carbon atoms. You can see here just only a single bond is present. That means 3 hydrogen atoms are surrounding this carbon and making this bond as 4. Right? So if in a compound only a carbon is given, then we should have to see whether it is making a single line or a double line. If it is making a double line, that means in between the carbons double bond is present. If it is making three lines, that means in between the carbon 3 bonds are present. So if in between the carbons 2 bonds are present, that means how many hydrogens are left here? 2 hydrogens are left here, as 2 bonds are left still for the carbon. That indicates there are 2 hydrogen atoms are present. Right? Okay. So to draw a bondline formula, it's very easy to draw a bondline formula for a compound. So if you're drawing so, it will be very easier for you to understand anything. To confuse in the examination, what they will use to do is that they will give you the bondline formula instead of like this. So you should have to learn bondline formula for sure. Okay, you got it? Okay. Now if I am saying you to draw the bondline formula for this compound, let's see how I am going to draw the bondline formula for this compound. You can see here, what I am going to do is that first 1, 2, 3, 4, 5, 6 carbons are there. You can see here 6 carbons are there. So if I am drawing a line, 2 carbons are there. 2 carbons are there. One more line is a 3rd carbon. One more line, 4th carbon. One more line, 5th carbon. One more line, 6th carbon. How many carbons are there? You can see 1, 2, 3, 4, 5, 6 carbons are there. So whatever I drawn the structure here is correct? No. Why I am saying is that you can see here we should have to see the bonds too. You can see here in between the carbon a single bond is present, single line is present. In between the carbon single bond is present, single line is present. In between the carbon single bond is present, single line is present. But here in between the carbon double bond is present. In between the carbon double bond is present, right? 1, 2, 3, 4. 1, 2, 3, 4. That means in between the carbon here a double bond is present. That means a double line should be present, right? You can see here a double bond should be present. That means we should have to draw double line in a bond line formula. Right? As I am drawing the double line, you can see now this compound and this compound is same. Right? So this dotted points indicates that it is a carbon atoms. Right? So you can see here how this carbon is making 3 bonds, one with this carbon, one with this carbon, and two with this carbon, right? These 2 carbons, with these 2 carbons, this carbon is making 3 bonds and 1 bond is left. That means where is that 1 bond? That hydrogen is making that 1 bond. So that means here how many hydrogen atoms are present? 1 hydrogen atom is present at this point of carbon. At this point, and this point indicates it's a carbon atom. That means this carbon is making 1 bond with the hydrogen. Right? Here it is making 3 bonds with the hydrogen. Right? Here it is making 3 bonds with the 3 hydrogen atoms. Here 2 bonds are made. Then 2 bonds are still left. That means those 2 bonds, this carbon is making 2 bonds with the 2 hydrogen atoms, right? Hydrogen atom can make only a single bond. You can see here 3 hydrogen atom is making 3 bonds with this carbon. You can see here how many hydrogens are making only a single bond. Hydrogens are making only a single bond, right? So hydrogens are making a single bond, carbons will make 4 bonds, right? So to make a bondline formula is very easy for a compound. If you know, then it will become easier for your examination too, because in the examination to confuse you, because most of the students will practice in this way, so that they will use to give in this method of bondline formula, so that you will get confused and you will not get the answer too sometimes. So you should have to understand the Bondline formula. So instead of practicing like this, I know everyone would have practiced like this so better, but now we should have to practice like this. So instead of now, from now onwards, instead of giving like this, I will give you the Bondline formula for all the compounds. Right? Yeah. So we are studying about unsaturated organic compounds. How to name the unsaturated organic compounds. So in an unsaturated organic compounds, we will see the double bonds and triple bonds. In this compound, I can see the double bond. This compound and this compound is the same. In this compound, I am seeing the double bond. So how to name? As you can see here there is no substituent present. So nothing to worry. It is not a complex compound too. It is a simple organic compound. But it is an unsaturated organic compound. So what I am going to do is that here there is no primary prefix. You can see how to write the order of names. Here there is no primary prefix. Primary prefix plus secondary prefix, the root word plus primary suffix plus secondary suffix. It is the way to write the name. Right? So what is the primary suffix? You can see here there is no primary prefix, as there is no root word. As there is no cyclic compound. It is not a ring compound, right? It is not a ring compound. So here there will be no prefix. Secondary prefix. Here you can see any secondary prefix. No. Here there is no substituents and there is no functional groups with respect to the secondary prefix. We studied 4 functional groups with respect to secondary prefix, which comes under the secondary prefix, which are nitro, nitroso, alkoxy and halo. These are the 4 functional groups which comes under secondary prefix. And then root word. What is the root word here? Meth, eth, prop, but, pent, hex. Here 6 carbons are there. That means what is the root word for 6 carbon atoms present in a compound? Hex. Right? And then plus primary suffix. What is the primary suffix? Primary suffix indicates the nature of bonds present between the adjacent carbon atoms. So adjacent carbon atoms, adjacent in between the carbons, how many number of bonds present? That is what our primary suffix gives us the information. So if in between the carbons single bond is present, then it is ane. In between the carbons if double bond is present, then ene. In between the carbons if triple bond is present, then ine. You can see here in between the carbon, at one point you can see here in between the adjacent carbons you can see a double bond. That means in the carbon you can see in this chain, in this compound you can see at one point, at one place in between the adjacent carbons as double bond is present. So if double bond is present in a compound, then we will give the secondary and then we will give the primary suffix as ene. Right? Here ene. But while giving the name ene, we should also have to give the numbering. In unsaturated organic compounds, we should have to give the numbering too. If it is a simple organic compound, that means saturated organic compound. Saturated organic compounds means in between the carbons a single bond will only be present. Unsaturated means in between the carbons double bonds and triple bonds are present. Whenever we are talking about the unsaturated carbon compounds, we should have to understand, we should have to give the numbering where this double bond is present. At which carbon this double bond is present, we should have to give the numbering. So as we studied in the substituents, whenever we are seeing the substituents in the complex compounds, what we will do is that we will take the least numbering, like least number rule. We will follow the least number rule. Right? That means our substituent should have to get the least number. We should have to give the numbering in such a way so that my substituent should have to get the least number. The same method we should have to apply here too. What we should have to do is that we should have to give the least numbering to the carbon where the double bond is present. If I am giving the numbering from this side, it is 1, 2, 3, 4, 5, 6. That means at the fourth carbon, double bond is present. When I am giving the numbering from this side, 1, 2, 3, 4, 5, 6. You can see here at the second carbon a double bond is present. Then which is the least number? 4 is the least number or 2 is the least number? 2 is the least number. That means we should have to give the numbering in this way. If we are giving the numbering in this way, then only we will get the double bond carbon at the least position. Right? So here what we should have to write, we should have to give the numbering and we should have to write the numbering here 2 at the second position. this double bond is present. At the second carbon of the compound, this double bond is present. Right? We should have to give the least number to the carbon. We should have to give the numbering in such a way so that it will get the least number. So hex plus 2-ene. Here there is no secondary suffix because here there is no functional groups. Then what is the name of this compound? Hex 2-ene. Got it? So this is how we should have to name the unsaturated organic compounds. We will see some more examples. So I am just now going to give you through a Bondline formula. Through a Bondline formula, we should have to understand everything. Right? You can see here. Okay. You can see here. Here, both the double bonds and triple bonds are present. Here, how many carbon atoms are there? You can see here 1, 2, 3, 4, 5, 6. Each point is representing a carbon atom. Here, 6 carbon atoms are present, right? So, how to write the name of this unsaturated organic compound? Here, both the double bond and triple bond is present. How to write the name? We should have to write the primary prefix first, then secondary prefix, followed by root word plus primary suffix plus secondary suffix. So, is there any primary prefix there? No, it is not a cyclic compound, so there is no primary prefix. Any secondary prefix? No secondary prefix, as there is no substituent here, as well as here there is no functional groups related to secondary prefix. What is the root word here? How many carbon atoms are there? We should have to check. 1, 2, 3, 4, 5, 6 carbon atoms are there. If here 6 carbon atoms are there, then what is the root word? Hex. If 6 carbon atoms are present in a compound, the root word for the 6 carbon atoms is hex plus primary suffix. What is the primary suffix? Primary suffix gives us the information about the number of bonds present in a compound, present between the carbon atoms. How many number of bonds present between the carbon atoms? You can see here both the double bond and triple bond is present. Here both the double bonds and triple bond is present. Then what we should have to do? If the double bond and triple bond are present at different positions, then we should have to give the number in such a way. So that any one of the unsaturated group, that means any one of the double bond or triple bond should get the least position. If I am giving, so you can see here, if I am giving the numbering 1, 2, 3, 4, 5, 6. If I am giving the numbering like this, you can see at the second position I am giving my double. I am seeing my double bonds. Right? At the second carbon I am observing my double bond. At the fourth carbon I am observing my triple bond. If I am giving the numbering this way, 2, 3, 4, 5, 6. You can see here too at the second position I am getting the triple bond. So whenever I am giving the numbering from this side or this side, I am getting my one of the double bond or triple bond at the same position. Here too I am getting at the second position I am getting the double bond. Here too I am getting the triple bond at the same position. If this triple bond is not here, if this triple bond is here, then you can see here at the first position I am getting my triple bond. Here at the second position I am getting my double bond. So as I am getting at the first position triple bond, whatever the numbering I given in this way, 1, 2, 3, 4, 5, 6 is correct. Because we should have to see in such a way so that any one of these bonds, any one of the double bonds or triple bonds should come first, should get the least number. You can see here when I am giving from this side, you can see for the double bond it is getting the least number as 2, but for the triple bond I am getting the least number as 1 when I am giving from this side. So I should have to choose the least number. Right. So you can see here it is the correct one. It is the correct way of giving the numbering for this compound. Right. So what should I have to do is that I should have to give the numbering. I given the numbering to and I given the correct numbering. I selected the least number carbon which is having that double bond or triple bond, which is the triple bond, right? So what I'm going to do is that I'm going to write the name. if triple bond is present, what should I have to write? We should have to write for the triple bond YNE, ein. In the primary suffix, we should have to write the name for the primary prefix as ein. If double bond is present, we should have to write the primary suffix as in, right? Unfortunately, the camera has been stopped. Now it is resumed. Yeah. So I have been saying that we should have to give the preference to the least number rule. We should have to check either one of these two. Anyone should have to get the least position. As you can see here, as here triple bond is present, it is getting the number 1 whenever I am giving numbering from this side. You can see here, so it is getting the least number. So we should have to give the numbering in this way, right? If you are not understanding the least number rule, you can also apply the lowest number rule for the two substituents or more than one substituent. What we will do is that we will apply the lowest sum rule. We will add those two numbers where the substituent is present, and then we will see the results of those two numbers after giving the numbering, and in which the number has been less or which is having the less number, that way of numbering will be chosen as the correct one. So you can see here, I am just applying the lowest number rule here. If I am applying in this way, you can see here number 2 and number 5 is the number at which this double bond and triple bond is present. If I am adding, I am getting the result as 7. And this side, whenever I am giving the numbering, I am getting the position 1 plus I am getting the position 4. At the position fourth carbon of this compound, at this position I am having the double bond. At the first position I am having the triple bond. Whenever I am adding this one, I am getting the result as 5. And which is the lowest number? 5 is the lowest number when compared to 7. Then whatever I chosen the numbering in this way is the correct one, as I am getting the lowest number. Right? We can apply here to this one. In the substituent case too, it is the same, and in the unsaturated organic compound too, it is the same if double bond and triple bond is present in the same compound. Right? So here for the triple bond it is ein, for the double bond it is in. Right? As this triple bond is getting the number 1, it doesn't mean we should have to write the ein first. While writing the primary suffix, or while writing the secondary prefix, while writing the substituents too, or while writing about the unsaturated functional groups, or you can say unsaturated organic compounds like double bonds and triple bonds, we should have to write in alphabetical order. We should have to see first whether it is ein or in, and then according to that we should have to write in alphabetical order irrespective of the number. Here, as it is getting the number 1, it doesn't mean we should have to write the first as ein. We should have to write in first. So why I am writing in first? Because E comes first in the alphabetical order when compared to the Y. Right? We should have to write the in first. And what is the numbering? We should have to give the same numbering, 4 in, and it is 1 ein. Right? 4 in and 1 ein. It is how we should have to give the numbering to the unsaturated organic compound. And what is the name for this one? Hex 4 in 1 ein. It is how we should have to find out the name for the unsaturated organic compounds. I will give you one more example. What I done is that I'm just changing the whole situation right now. Yeah, I'm changing the whole situation. Wait. Here 6 carbons are present. 1, 2, 3, 4, 5. 6 carbons are present. And here triple bond is present, and here double bond is present. You can now see here. What I'm going to do is that I'm going to give the numbering for this compound. 1, 2, 3, 4, 5, 6. Right? In this way I'm giving the numbering, and in this way also I can give the numbering 1, 2, 3, 4, 5, 6. So you can see here, in both the cases you can see here, when I am giving the numbering from this side, you can see at the second carbon I am getting the double bond, and at the fourth carbon I am getting the triple bond. And when I'm giving the numbering from this side, you can see at the second carbon I'm getting the triple bond, and at the fourth carbon I'm getting the double bond. I told you either one of these, whether it is double bond or triple bond, either one of these has to occupy the least number, has to occupy the least position, right? But you can see here both are at the same positions. Whenever I'm giving the numbering from this side or from this side, these two are getting the same position. Then at that time, how we should have to decide in which way we should have to give the numbering. If the numbering is same in both these sides, then we should have to give the preference to the alphabetical order. So in alphabetical order, it is in and it is ein. So whenever I am seeing the alphabetical order, I am seeing that in is coming first. Then we should have to give the preference to the in. That in should have to get the least number. So you can see here, this in is getting the least number at second. That means this numbering is the correct one, because 4, when compared to 4, 2 is the lowest number. So it is the least number, you can see here. So we should have to give the numbering in this way. We should have to consider the alphabetical order only when both the double bond and triple bond are the same position when I am giving numbering from both the sides. Right? So you can see here, as I am giving the numbering from both the sides, this in and ein, that means this double bond and triple bond, both are coming in the same position. Both are coming in the second carbon. Both are occupying the second carbon. So at that time we should have to give the preference to the alphabetical order. As in the alphabetical order, this double bond comes first. Then we should have to give the preference to this double bond. This double bond should have to get the least number. So what is the rule of writing the compound? Primary prefix plus secondary prefix plus root word plus primary suffix plus secondary suffix. Here there is no primary prefix, as it is not a cyclic compound. Here secondary prefix, no secondary prefix, because here there is no substituent. Third one, root word. How many carbon atoms are present? 6 carbon atoms are present. What is the root word for the 6 carbon atoms? Hex. Plus primary suffix, we should have to see the bonds between the carbons. Here double bond is also present, triple bond is also present. Then as double bond is present, we should have to write double bond is first, because the primary suffix used for the double bond is ein, which comes first in the alphabetical order when compared to the ein. And I already given the numbering too. We should have to write with the numbering. So 2 in and 4 ein. It is the name of this compound. You can see here, hex 2 in 4 ein is the name for this unsaturated organic compound. So it is how we should have to name the unsaturated organic compound. So if instead of triple bond, one more double bond is present, if instead of triple bond, one more double bond is present, then the procedure is the same. What should we have to do is that we should have to see which double bond is getting the least number. As both the double bonds are getting the least number in both the angles, then we can take any one, because both are double bonds, both are in. Here there is no alphabetical order, right? Because both are same. So we should have to take any one of the numbering, right? I am going to write this one. Here there is no primary prefix, no secondary prefix. What is the root word here? 6 carbon, that means hex. Plus, what is the primary suffix here? Here 2 double bonds is present. If 2 double bonds is present in a compound, if 2 double bonds are present between the carbons in a compound, then we should have to write it as diene, right? Diene we should have to write. We would have studied in the primary suffix. You can see here, if 2 double bonds are present, then we should have to use diene. So you can see here, we should have to give the numbering to what is the numbering at the second carbon it is present, and at the fourth carbon too it is present. Then we should have to write 2, 4 diene plus no secondary suffix, because here there is no functional group. Then what is the name for this compound? Hex 2,4 diene. So it is how we should have to give the numbering, and it is how we should have to write the name for an unsaturated organic compounds. Now you would have better understood how to find out the names for a simple organic compound, how to find out the names for complex organic compound and unsaturated organic compound, and how to give the numbering, how to select a parent chain, and what is the order of name, how to write a name, what is the order of that one to write the name. you would have better understood from these 3 lectures. So in the next lecture, I will come with so many questions, so many creative questions in order to discuss with you. So let's take care of yourself and study well, do well, focus on your aim, and all the best, my dear friends.